Hey guys, this is video 7.5, predicting products. Now this is something that is an important skill. How much of this you have to do on the reagents kind of depends from year to year. So we're going to practice this. This is not going to be the only time that we're going to do this, but we're going to keep practicing it throughout the whole year. Okay, so you probably will see at most one, maybe two questions like this on the reagents. So just keep that in kind of perspective with it. Let's jump right in. We are going to be on page number 14 if my tablet isn't going to be stupid. Okay, so what I have for the notes here is just a practice worksheet. We're going to do kind of 3 or 4 of these together, and then you guys are going to practice the rest on your own. All right, so the first thing we have to do in predicting products is we got to identify what type of reaction we have. Okay, so number one, we're going to take a look. Now, all of these are in words. You've got to write the formulas. That's going to help you out tremendously. So we've got to go through and do that. Now, the way you should be thinking about this is, one, when I read the names, do I see prefixes? If I don't see prefixes, I know that it's an ionic compound and I should be using the crisscross method. Okay, don't be too lazy to do this. Magnesium, Mg, 2+. Bromide, which is bromine, 1-. So I'm going to take that to get my formula. Bam. MgBr2 is what I would have for this. If you don't write the formulas correctly, predicting products and then balancing your equations, guys, is going to be a nightmare. You have to be able to go from a name to a formula. Otherwise, you're not going to be successful in this class. So if you struggled with this, get some extra help. Come in and see me. All right, magnesium bromide plus chlorine. Now, how are we going to write chlorine? Is it just this? Absolutely not. First thing you should write on your page whenever you're doing any practice or taking a quiz or something, guys, even before you write your name, is write Brinkelhoff. That's going to help you remember that when you see one of those elements by themselves, they exist in the diatomic state. So it's MgBr2 plus Cl2. Now, here comes the predicting products. So to be able to do this, to be able to write our products out for a reaction, we have to classify the reaction, and then it's going to be pretty easy from there. So if I take a look here, I've got a compound plus an element. Which reaction type is a compound plus an element or an element plus a compound? That's going to be a single replacement reaction. Okay, so just by looking at your reactants, you should be able to tell or identify what type of reaction it's going to be. All right, so now the question is, well, who's going to replace who? So if you remember from the last video, we said that likes replace likes. Well, let's identify what type of elements we have. So magnesium is a metal, bromine is a nonmetal, chlorine is a nonmetal. Now, single replacement reactions, guys, we have this thing called the activity series. So we're going to go talk about that right now, and then we'll come back and do more with this. Flip over to page 17 in your notes. Okay, and mine is going to be already written out, so which I don't want. So I'm going to erase it. So, what is the activity series? Go through and identify that, answer these first 2 questions. I'm not going to write them out because this is a vocab term, so you should be able to write that down. Now, where are the most active elements found in the series? They're going to be at the top of your series, of your chart. Okay, so when we talk about the activity series, guys, this is table J. This is going to be something that's very important that you will have to use. I guarantee you you're going to have at least one question on the reagents using table J. At least one, probably more than one. But we'll talk more about it throughout the year, especially when we do redox reactions. So top of the list is going to be where the most active are. So we're going to flip over to table J right now. Okay, so you've got 2 series when you take a look at it. Okay, you've got the most active, you've got your metals, and you've got your nonmetals. Okay, so this is why it's important to be able to identify which one's which. So the higher up you are, the more active the metal is. So lithium is going to replace any other metal in a compound when it's by itself because it's so active. Whereas gold is the least active. Think about these last 2. Silver and gold. Where do you find silver and gold most of the time, guys? Jewelry, right? Maybe you didn't think about that. Maybe you did. But you can kind of know how cheap your jewelry is by how much it reacts with your skin. If you have any jewelry that becomes like blue or greenish, that's not real gold or silver. Sorry to ruin the whatever I'm ruining there. But that's typically copper that's plated with maybe some chrome or some silver of such that wears off. But gold and silver, guys, they're least active. That's one reason why we use them as jewelry and other things, because they don't react with other stuff. All right. And then also you've got your nonmetals. Now specifically, guys, it's just the halogens you want to be on the lookout for. All right, just these 4 halogens that will replace it. So if it's higher up on the list, it's going to be more active. It'll replace an element, and you'll see what I mean as we get into some more practice. So what I want you guys to do right now, pause the video, go through, based on the activity series of the metals and halogens, circle the element within each pair that's more likely to replace the other in a compound. So pause it and go back and look at using table J and figure out which one's which. Okay, so potassium is more active, chlorine is more active, aluminum is more active, strontium is more active, chromium is more active, fluorine is more active, fluorine is more active, and silver. All right, pretty simple to use table J. You've got to know where it is and where to look for it. All right, that's the big thing. Now what we're going to do, specifically for single replacement reactions, we're going to identify, will this reaction actually take place? So we would go and look, okay, I've got nickel is trying to replace, which one's it going to try to replace? It's going to try to replace copper because nickel's a metal and copper's a metal. So I'm going to jump over to table J and look for those 2 elements. All right, so I'm going to erase what I had already up there. So I'm in my metals column and I'm looking for those. I see, okay, here's nickel and here's copper. So ask yourself, is nickel more active than copper? Absolutely it is, because it's higher up on the list. That means this reaction that we have right here is going to take place. Nickel is going to come in and kick out copper, so we have a new compound that's going to form. It's going to be nickel chloride, nickel 2 chloride, plus copper. The only way a single replacement reaction will take place is if the element that's by itself is more active than the one it's trying to kick out. Otherwise, it doesn't have enough juice to switch spots with it. All right, it's not strong enough to cut in. Let's look at another example. Okay, we've got zinc. Who's it going to try to kick out? Well, zinc is a metal, so I'm looking for the metal over here. Oh, that's lead. Will zinc be more active than lead and actually let this reaction take place? So I'm going to look at table J. Here's zinc. Where's lead? Oh yeah, lead's way down here, so zinc is much more active, meaning that this reaction will actually take place. Zinc's going to come in, kick out lead, so we're going to get zinc nitrate plus lead. All right, and that's what it looks like. So what I want you guys to do is to go through and do these next 3 on your own. If something is less active that it's trying to kick out, or the single element that's trying to kick out something else, you just write no reaction, because no reaction would take place. So pause the video, go through, do these ones, and then we'll jump back to our other predicting product pieces. All right, next one. Chlorine is going to try to kick out iodine. So I'm going to go over here to table J. I'm going to see, is it more active? Chlorine's right here, iodine's at the bottom. Bam, that one will take place. So now we're going to get KCl plus iodine. You might be asking yourself, well, why is it KCl, not KCl2? Well, go back, guys, and look at your charges. Excuse me, potassium is a 1 plus, chlorine is a 1 minus when we do our crisscross method. So when we predict products, that is the only time we can change subscripts. We do not change subscripts when we balance equations. We only do it when we predict products. And remember, most of the time you're not going to be predicting them. So this would be it. We'd have to balance it, put a 2 there and a 2 there. All right, next one. Copper is going to try to kick out iron. Let's go to table J and see if this will actually take place or not. So copper is all the way down here. Iron's right here. So this one, copper's lower. This will not take place. So all we have to do when we see that is say no reaction. Copper's not strong enough to kick out iron. And the last one, barium's going to try to kick out hydrogen. Now I know hydrogen, guys, is a nonmetal. But remember, in an ionic compound, hydrogen typically is going to act like a metal because it's going to donate those protons and give them away. And notice, guys, where hydrogen is. Hydrogen is on the metal series. Barium's way up here. That reaction will take place. So we would get a final product that's going to be barium hydroxide plus H2. Remember, writing water as HOH. Okay, barium's going to come in and kick out just the hydrogen, not all of it, because the other part is hydroxide. And again, that's a trick that's going to be something we'll learn more as we go on. Okay, so that's the activity series. Let's jump back to our other page and learn how to predict the rest of the types. Okay, so single replacement reaction. Chlorine is going to try to kick out bromine. We would look on table J. If you look there, chlorine is more active. So now, when I write my products, this is what I was talking about just a couple minutes ago, rewrite your charges. So magnesium is 2 plus. Chlorine that it's now bonding with has a 1 minus. So I'm going to rewrite and make a new compound. All right, MgCl2 plus. Now bromine by itself, what's its subscript going to be? If it's by itself, it's going to have a subscript 2 because it's part of Brinkelhoff. Here's the note, guys. Just because there was a 2 on the left side for the subscript, in this case, doesn't necessarily mean it's going to be the same subscript on the right. Only when we're predicting products can we change subscripts. We never change them when they're balancing, okay? But they may not be the same when we have to predict the products. Let's jump into do another example. So I've got aluminum here. That's easy. Is it part of Brinkelhoff? Nope. Iron 3 oxide. Write out your charges. Iron 3 plus, O2 minus, crisscross, crisscross. So our formula is going to be Fe2O3. What type of reaction do I have? Well, I got an element plus a compound. Oh, that's a single replacement. If it's single replacement, we've got to jump over here and look at our activity series. Okay, so I'm looking for aluminum and I'm looking for iron. Will aluminum kick out iron? Absolutely, because it's higher up on the list. So that means this reaction will take place. So now aluminum is going to come in and kick out iron. So we're going to get iron by itself plus our new compound. Take the 5 seconds, write out the charges. Al3 plus, O2 minus, do the crisscross method. So it's going to be Al2O3. Last thing you need to do is to make sure you balance the equation. I've got 2 irons on the left. I need 2 right here. I've got 3 oxygens on the left, 3 on the right, and then I need a 2 right there to balance it out. It's a process, guys. If you try to skip steps and you try to miss, and you're going to miss things, and it's going to be more challenging. Take the extra time to think through things. Number 3, silver nitrate. So I've got Ag. That's a 1 plus charge. Nitrate. Oh, it ends in 8. That T sound. So it's a polyatomic. I'm going to look at my polyatomic list. That's 1 minus. So that's going to be AgNO3. All right, plus zinc chloride. So zinc is 2 plus. Chloride, 1 minus. Oh, I got to do my crisscross method. So it's ZnCl2. All right, so I've got those written in formula mode. Now I got to ask, well, what type of reaction do I have? Well, let's see. I've got a compound plus a compound. What reaction type has compound plus compound? It's a double replacement reaction. So with double replacement reactions, guys, we split up their ions. We're going to switch partners. This is that square dancing method that I was talking about before. So the best way to do that is, oh, look, okay, can 2 positive ions go together? No, they can't. You got to have a cation and an anion. So what I'm going to do, if you remember back like to math class, your FOIL method, first and last are going to go together, and then my insides are going to go together. All right, and we're going to rewrite new formulas. So silver is going to pair with chlorine. Okay, since it's ionic, I still need to look at the charges and always do the crisscross method. So that's going to be an easy one. So it's going to be AgCl plus, rewrite the new one. So zinc is now pairing with nitrate. Oh, this is going to be a little bit different. So now it's ZnNO3. Notice that's in parentheses. My subscript to balance out is going to be on the outside of the parentheses. Why it's so important to always put parentheses around your polyatomics. So now I would have silver nitrate plus zinc chloride yields silver chloride plus zinc nitrate. Last step you always got to make sure you do, balance the equation. Well, I've got 1 silver, 1 silver. Those are good. 1 zinc, 1 zinc. Those are good. 1 nitrate, 2 nitrates. So I need to put a 2 there and a 2 there. And then I'll check, okay, 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 1 zinc, 1 zinc, 2 chlorines. Oh yeah, look, 2 chlorines. Now I know there was a lot in there, guys. This takes practice. Okay, you've got to practice this. So we're going to do one more together, and then you're going to practice 5 through 8, and then you can ask for help in person. The biggest thing is you got to identify the type of reaction and then follow what you're doing in that type of reaction. Number 4, hydrogen peroxide, H2O2. Oh, look, it says catalyzed by manganese dioxide. Guys, catalyst. So think back to your reaction symbols. How do you show a catalyst? Oh, yeah, you put it over the arrow. So manganese dioxide, MnO2. Remember, the catalyst does not take part in the reaction. So you don't have to worry about it. It just stays over the arrow. What this is going to break down into, now this is a challenging one. This is actually going to break down into water and oxygen gas. All right, so again, the ones that you would have to predict on the regions, guys, they're going to be pretty straightforward, okay? You're probably not going to see a decomposition reaction unless they tell you what the products are. You're probably not necessarily going to see a synthesis reaction unless it's just a binary one like number 7 is, okay? So this is what your products would be, breaking down, then balance it, and you're good to go from there. So 2H, 2 H's. Ooh, oxygens. Well, this is a 1 oxygen, so I've got 3 total. Let's get this to be an even number. Okay, so now I've got 2 plus 2 is 4 oxygens. Well, I need to have this, and then it's balanced like that. Let's do one more together because that one kind of just took care of itself. 5 you're going to do on your own. 6 you're going to do on your own. Let's talk about number 7. Okay, so I've got sodium plus hydrogen. Now, when you see 2 elements, guys, you can assume it's going to be a synthesis reaction, okay? It can't be single replacement, can't be double replacement. It's not going to be decomposition. It's not combustion either. It's going to be synthesis. They're going to come together. So, again, same thing. Write your charges, okay? Since sodium has to be that +1, guys, hydrogen now is going to be that 1-. So, crisscross them over. NaH. And then balance them. All right, so this is something, guys, it's may not get it right away. It's going to take practice. Don't give up. Make sure you do the practice because you could very well see this on the Regents exam. All right, if you have questions, see me in class. Until next time, I will see you later. Stay classy.